Alrighty, 7th graders, welcome to part 2 of lesson 15.3. We left off where I wanted you to do with these questions. If you haven't done it already, I'm just going to go ahead and write in my answers here in just a minute. But if you haven't already, please stop the video and go through and answer these questions. Make sure that you have already watched part 1 as well, because obviously then you're not going to be able to understand how to solve these problems, okay? So if you already got your answers, just continue on. If you haven't, go ahead, pause, and answer these out. Alrighty, coming on back, here are your answers for these problems. So your theoretical probability, if you go back in example 1 and take a look at all of our letters, sorry, example 3, go and take a look at all of our letters. There's a total of 7 letters, only one of them is an X, so your probability is 1 out of X. This one, theoretical probability of spinning an odd number in a spinner is 0.6. Remember, probability can be written as a fraction, a decimal, or percent. We know how to change our percents to fractions, and so all I did was change 0.6 or 6/10 and wrote it as a fraction. Since there are 10 spinners on this section, which we have here, how many sections are odd? It's just the numerator of this, which is 6 sections. And your last one, example 4. Sorry, I think I'm going to sneeze. Sorry, guys. Example 5 here, you have to go back into example 4. The same probability still stands for getting a bobblehead, so it's 1/6. And this time they told you how many times you spin the wheel, or it was spun at this game. So that one has to go on the bottom this time, and we want to know how many bobbleheads would you expect. That we were 1, because maybe you're trying to figure out how many bobbleheads you need to buy so that you don't run out. And so I did my cross products for this one, and I get 6x equals 540, divide by 6, and I get 90. So I should expect that I should have at least 90 bobbleheads, if not more. All right. I think we got one more example, and then we'll talk about your homework. All right, might be a little weird for me. Let's go here. So it says the bar graph shows the results of rolling a number cube 300 times over a dice. Okay. What is the experimental probability of rolling an odd number? So you decided to sit there and roll this dice 300 times, okay? Remember, your experimental probability is what are the actual outcomes of this experiment, and I want to know my odd, okay? So again, it's going to be out of the total. My total is 300, and then we're going to figure out how many were odd. So we've got odd number 1, which is 48. 48 times we rolled that. How many times did we roll 3? It looks like 50. And how many times we roll 5? We rolled it 49 times. So let's go ahead and add those up, see if we can simplify my fraction here. What is this going to be? Almost? Well, it'll be like I'll just add it. 147 out of 300. I wonder if this is divisible by 3. It is. All right. So if I divide both the top and the bottom by 3, then on 147 divided by 3 is 49, and 300 divided by 3 is 100. I think that's as best as we can do here. So again, simplify it as best as you can. So your chances of rolling an odd is 49 out of 100. Again, it's very close to that theoretical probability of 50 out of 100. So this is exactly what I just said. How does the experimental probability compare with the theoretical probability? Remember, your theoretical probability is what you would expect. So if I rolled this dice 100 times, I would expect that I would get 50 of them to be odd because that's half the numbers. So I would explain that they are very close, closely related. Meaning that I get about the same answer. I'm just one off on this one, and that's okay. I'm going to expand this a little bit so it's easier. Bloop, bloop, bloop. And then C. What does part C say? Compare the experimental probability in part A to the experimental probability in example 1. Oh, okay. So let's go back to example 1 and look. Oh, we got to go through a lot of slides here. All right, so example 1, when we were talking about rolling this dice, we got an experimental probability of 12 out of 25. So let's go ahead and look. 12 out of 25. Okay, so 12, oops, that's right, 12 out of 25. If I was going to put this as a denominator of 100, I would be multiplying it by 4. I'm just creating an equivalent fraction right now so that I can easily compare the two numbers. Again, if you have fractions, it's easier to compare them when they have the same denominator. So I'm going to multiply this by 4 and 48. Hey, they're also very similar. Okay, very closely related. Or you could say, or similar. I get similar answers, only one smaller than the other. All right, so it's just comparing and seeing, are they completely different? Did your experiments be weird? I don't know. All right, let's actually do this one. Go ahead and pause this. So you're going to use the example here from example 5, okay, to find the experimental probability of rolling a number greater than 1. So what's the experimental probability of rolling a number greater than 1? And what's the theoretical probability of rolling a number greater than 1? I want you to be able to compare the two, so that's why we're going to do this one, okay? So again, you have to, in experimental, you're going to count up how much here, simplify it out of how many numbers, and then your theoretical probability is going to be rolling a number greater than 1, okay? So go ahead, pause the video, answer out these questions. I will see you when you get back. All right, coming on back. So actually the easiest one to solve in this one is your theoretical probability, because you're just going to try and figure out what are your favorable outcomes. Well, any number that is greater than 1. So that's things like 2, 3, 4, 5, and 6. So that is 5 numbers. There's a total of 6 numbers. You get 5 out of 6. Okay. Your experimental probability it's a little more harder. Your 300 goes on the bottom because you did 300 trials. The number of times you got a number that was greater than 1 was 252. And then I just simplified it. So I started by dividing by 3, which I get 84 divided by 100. Divided that by 2 and divided by 2 again until I got 21 out of 25. Now they want me to compare the two. And like I said, when comparing fractions or ratios, you're going to want your denominator to be the same. And it's going to take me a while to get these to be the same. It's going to take a lot of work. So we're going to actually change these into percentages. So I'm going to change this into a percentage. So I can use my calculator if I want. I would do 21 divided by 25. Looks like 0.84. Remember, when we want to change it to a percent, we move the decimal 2 to the right. So I would have 84%. Let's go ahead and throw this one in a calculator. 5 divided by 6. Oh, it's like 83.333. So we're going to have 0.833 repeating, but we're going to move the decimal 2 places over to have my percent. So I'd have 83.3%. So if I'm going to compare these, again, I would say they're similar. But you could say something like experimental was higher than theoretical. I just abbreviated them so that it wasn't quite as much work to write them out. All right. And your last part, your homework here, let's talk about it. It is 15.3 on Big Ideas Math. This assignment is going to be due here on the 20, I think that's the 20, I keep forgetting the dates. 24th? Yeah, Sunday the 24th. Okay, so make sure you get that Big Ideas homework done and turn it in. Make sure, I think I forgot the code word again, guys. Dang, I'm doing so awful, forgetting at the end. Code word is noodles for this one. Okay. So make sure that you go and do your Big Ideas Math for today, and then I will catch you in the next lesson tomorrow. Okay, see you later.